Okay, so we'll try to resolve this exercise, and before that we should give a definition of what is a transitive class. So a class A is said to be transitive if and only if we have the big union over A is a subset of A, which means for all elements A, for all set X, A is belongs to big A and X belongs to A, thus imply X is an element of big A, which means if we have this situation, X belongs to A and A belongs to A, then we have X belongs to A. So when we have a class like this, we say that A is transitive. Okay? And what is ordinal? Ordinal is just a class, a transitive class. A is ordinal, or O, okay? O is ordinal if O is transitive and for all little o in O, O is also transitive. Okay, this is the definitions of transitive and ordinals. Okay, so based on this definition, let's start to resolve this exercise. Okay, we have first A. The singleton X is transitive if and only if X is the empty set. It is simple to start by this sense. So if X is the empty set, okay, then this class, it is transitive or no? Yes, it is transitive because for all X in this class we have what that mean for all X? Mean that X is the empty set. Is the empty set element of X? Yes, the empty set is an element of the empty set. So this class is transitive. Okay, so this sense is proved. The other sense, we suppose that X is transitive, and I will denote it great lambda, okay, big lambda, and I will show that X is coincide with the empty set. So we must have this situation for all y in V, for V in lambda, we should have y is an element of lambda. What that mean? Okay, for V in lambda, or lambda is x, it means that V is equal to x. Okay, so for all y in X, we should have y is an element of this class. Okay, for y to be an element of this class, we should have y equal to x. Okay, so we must have this situation: y is an element of x and y equal to x, or imply. What that mean? This imply that x is an element of itself, belongs to itself. Or we suppose that x is a set because it belongs to a class. So x, it's a set. So for x to be a set and verifying this property, we know that a set doesn't belong to itself. Okay, so it's absurd. Then x is only the empty set, because it's the only set that verify this property. Okay, it's the only set for x to be, for this class to be transitive. Okay, if we suppose that x is different from the empty set, then we have contradiction. Okay, so it's good for the first A. So for B, V is transitive while this class is not. So we should prove two properties here. Why V is transitive? So what is V? V is the universe. We know that V is the universe of sets, which means all the sets. And we have a definition like this: is equal to x. Okay, so V contain all the sets. And why V is transitive? Because for all z, for all x, we have x in V and z in x. This, we have z in x. Z in x, it means that z is a set. And because V is the universe of sets, so z belongs to V. So V is transitive. Okay? So we proved that V is transitive. Why this class is not transitive? So I will denote A is the set of singletons x, and x belongs to V. Why this set is not transitive? So I will suppose that set is transitive, okay, which means for all elements y, for all elements x, we have x, or x belongs to V and y belongs to x. We should have y belongs to A. X belongs to V. Yes, and y belongs to x. It means that x is a set and y is equal to x. And we will have the situation: x belongs to E because x is equal to y for all x in V. So we will have this situation for all x in V. The singleton, no, only x is in E. So we proved that. What is wrong with this? The wrongest thing is that the empty set must be in E, or that mean for the empty set to be in E. So there exists a Z in V such that the empty set is like this, because the elements of E are like this, are the singletons. Or this is a contradiction because saying that the empty set is a singleton, it means that the empty set has an element, or the empty set is empty by definition. So this is contradiction, and E is not transitive. So we move to the C question. If x is transitive, then Sx is transitive. If alpha is ordinal, then S alpha is ordinal. So why, if x transitive, then Sx is transitive. Okay? We will assume that x transitive and we will prove that Sx is transitive. So I will denote A is the set Sx. We proved, we know already that Sx is a set. Okay? So we will prove that if we have Z in V in Sx, we should prove that Z must belong to Sx. Okay, so let Z be in V and V, or let V be an element of set of Sx and Z an element of V. Salam. So what that means, V is an element of Sx, or Sx, what is the definition of Sx? Is X union the singleton X. So V in this set, it means that we have two cases. The first case is V belong to this set or belong to this set. I will start by the easiest one, is that V belongs to X, which means V equal X. And what do we know about X? X is transitive, so Z, for Z belonging to V and V belong to X, and X transitive, so Z belongs to V. If Z belongs to V, Z belongs to X because X transitive. If we have Z belongs to X, so it belongs to X in union X, and this is S to X, S of X. So Sx transitive, it's not transitive, but we have this situation. If we have V belongs to the singleton X, then Z belongs to Sx. The other situation, the other case is that V belongs to x. What that mean? What that mean? No, this is what I say is wrong. We have the first situation. The first situation is that v equal to x, not this is the second. Okay, so z must belong to x because v is equal to x and z belonging to v, and v is equal to x, so I add an union, so I found this, so z belonging to Sx. So the other supposition is that v is an element of x. If v an element of x and x transitive, so for z belonging to v and v belonging to x, and x transitive, by transitivity of x we have z belonging to x. Okay, so in the both cases we have z belonging to Sx, so Sx is transitive. Okay, so and if alpha ordinal, then S alpha is ordinal. I will make a pause.